All right, so it's Friday afternoon, and if you're anything like me, all you want to do on Friday afternoon is draw supply and demand curves. What I have done is I've posted a bunch of practice questions along with a key. Some of you have done this for many, many years, some of you have not. So what this video is for is to go slowly through all of the examples so that you can see me actually graph them and talk about the graphs. I think that's something that's missing just trying to teach with textbook slides. So, number one, I asked you guys to use a graph of supply and demand to demonstrate what happened with the Beeple painting. I called it a painting. I don't know what it is, an NFT, piece of artwork. So the first thing I want to do is draw my supply and demand axes. Price goes on the y-axis, quantity on the x-axis. What I'm going to do is I'm going to draw the market for Beeple paintings, whatever they are, before the switch that I'm arguing happened. So I'm just going to draw typical demand, typical supply. I'm drawing a demand curve, a downward sloping line. Line is totally fine. Upward sloping line for supply. And I label it PE and QE, and this is how I start all my graphs of all time. There we go. Those of you who are a bit more advanced, you might notice I drew this like very steep, and that's to reflect inelasticity, but you don't need to know what that is just yet. All right, so I argue the reason that this switched is because of a change in expected future price. This guy's gonna get hot. These guys, these NFTs are gonna be like big money makers, and so what's gonna happen is, as we expect the price to increase in the future, demand today is going to increase. So I just draw a shift to the right. And supply today is going to decrease. Why is it going to decrease? If you're holding one of these things and you think that the price is going to increase in the future, then you're not likely to supply it today. So that we're talking supply today is going to decrease if we expect the price to increase in the future. You go to your new equilibrium, it's way up here, P2. I'm going to label it Q2 is equal to QE. The way that I drew the quantity, the curves, the quantity stayed the same. It's ambiguous. It could go either way depending on how you draw this. But the important thing to note here is that the price increased in a really dramatic fashion because we saw both a demand shift and a supply shift. So this is really the only thing that shifts both curves, besides substitutes in production, which we'll deal with later. Okay, so this is a self-fulfilling prophecy. This happens in the art world all the time. It happens in the finance world. We expect the price to rise, and then it does rise. It's worth noting this is a terrible model for this, right? Because we're assuming homogeneous goods, and clearly artwork is not homogeneous, but it's still a good approximation. Okay, so I'm going to erase this and then move on to the next one. All right, so the next one says, what's going to happen to the price of dried beans as the economy continues to recover? All right, first thing. Price, quantity, demand, supply, PE, QE. All right, so this is the starting point. We've got a price and a quantity. When I'm talking about the economy recovering, I'm usually talking about a change in income, but you can always ask for clarifications. But we're assuming as the economy recovers, incomes increase. They did actually increase in the last month, in July. The numbers just came out today. Incomes increased. So the real question is, are dried beans a normal good or inferior good? I believe them to be an inferior good. If you get richer, you might be more likely to buy a restaurant meal or a canned bean, right? People who cook with dried beans tend to be very price conscious. So incomes increase, demand for the inferior good is going to drop. P2, Q2, price drops, quantity drops. Okay, so that's number two. Number three, the price of computer chips increases. What happens to the market for electronic cars? it's a price of a related good. And at that point, we think, well, would this be a supply thing or a demand thing? Is it like consumers are deciding between computer chips and electronic cars, or is it like an input in the production of electronic cars? All right, and so this is a supply thing. All right, and actually I called it a price of a related good. You can actually just go ahead and call it the price of an input. PE, QE. All right, the price of an input increases, supply decreases. Note how I drew an arrow to the left, not going up, because we don't like to think up and down with the supply curve. The price of electronic cars is going to go up, the quantity is going to drop. Okay, so those are sort of the easier two, besides the Beeple one, which is weird. And then we're going to go into the simultaneous shifts. So I said, explain why the price of lobster increases in the summer when the supply of lobster is higher than it is in winter. All right. Lobster. Every time, I'm a big lobster fan. Every time someone eats lobster for the first time, they're always really underwhelmed. They're like, this is so expensive? Why is this so expensive? All right, so let's look at the question again. The price of lobster increases in the summer, even though the supply of lobster is higher. So let's draw the summer supply curve. Notice I've been calling them S1 and S2, or just S and S2. Sometimes you can just be more explicit. Summer supply, and I could even call this winter supply. Okay, so supply is higher in the summer. So if we just look at this, we see this, why this is a weird outcome, right? You would expect the price to drop. So the way we can solve this is by drawing a super big increase in demand. So like supply increases in the summer, but whoa, demand also increases a bunch. People are taking trips to Maine, they're eating lobster, whatever. So we're way over here now, but we can see the price has increased. And so that I would be looking for some sort of graph like this if this was on an exam. All right, what happens to the price of airline tickets over the holidays as more people travel, assuming airlines increase the amount of flights offered? All right. All right, so let's draw this. So non-holidays, we'll just say normal supply and demand. All right. More people travel and airlines increase the amount of flights. So we know there's an increase in supply because I told you. And we know there's an increase in demand because I told you. So really this is just a practice of what it looks like when you see a simultaneous shift. You'll notice here the new quantity is not ambiguous. That's increased quite dramatically. But the price, well, it went up a little bit for me. Half of you would have it go increase, half of you would have it decrease. It really just depends how you drew the graph, and that's what we call an ambiguous outcome. So if I ever asked you something like this, I would look back at your graph and make sure, like if I said, what would you do if this was your business? I would look at your graph and see what kind of price change you had, and then make sure your answer is consistent with whatever you found. All right. Rents. Good old rent control, classic example. I'm sure Milton Friedman taught this in the 80s. I'm sure he didn't like rent control. It's always what we use. All right. So a price ceiling, and I mentioned a binding price ceiling, which just means it's below the market clearing price, is basically, I always draw a price ceiling like this. Like, hey, you can't go above it. You can't go above it. So price ceiling, rent control. what happens is quantity demanded is here, quantity supplied is here, and you might call this shortage. Okay, so that's basically all I would ever expect to see on this sort of a graph. The opposite would be true with a binding price floor. It would be a surplus that's up here. All right. So I have 2 questions left. My guess is that these are the ones that you guys want the most help with. So if I run out of time, I'll record one more video here. Basically, what I've got here is the Gunderson Company, okay? We've got quantity demanded, 5,000. Okay, so it's 5,000 plus 0.5 times income plus 0.2 times advertising expenditures minus 100p. So the first thing I do is I ask you to find the demand curve. Now a demand curve is only going to have one independent variable, which is price. So these are things that we like hold constant when we look at a demand curve. The relationship between price of a product and quantity demanded of that product is inverse, holding other variables constant. So by holding these constant, we're literally putting values in there. So in my example here, I said if A is 20,000, I is 25,000, you literally just plug those in there, okay? So when I plugged these in there, I have my key with me. I got QD equal to 21,500 minus 100p. So that's the demand curve. So basically all the other stuff just kind of goes into the intercept here. I also asked you to find the inverse demand curve. So if I was to graph this, this is the dependent variable, that's the independent, I would be tempted to put this on the y-axis, but we know price goes on the y-axis. So all we need to do to get the inverse demand curve is get this over here and get this over here. Now again, some of you guys said you're a little bit nervous about the math, so I'm going to go through this slow. What you're going to do is first I'm going to put this over here. So I'm going to add 100p to both sides. Okay, so now this is minus 100 plus 100, that cancels out. And over here, I've got QD plus 100p is equal to 21,500. Now I want to get QD over on the other side, so I'm going to subtract it from both sides. Minus QD. Minus QD. So now I'm at, get back up here, 100p is equal to 21,500 minus QD. Now all I need to do is get P by itself. So I divide each side by 100. P is equal to 215 minus 1/100th QD. Why would I ever care about doing this? This is if I ask you to graph it. Now I have this in the form y equals mx plus b, mx plus b. So you can say this is the slope and that's the intercept. That's really the only reason that's helpful. I've also given you a supply curve. You're welcome to try out the equilibrium. I have it on the key. And I'm going to move forward to the last one, and it looks like I'm out of time, so I'm going to record one more video.